Swayam Prabha. Digital India. Educated India.
This maritime engineering, as you see, is a very special program which has got multidisciplinary input from mechanical, civil, structural, aerospace, naval architecture, chemical engineering, electrical, electronics, applied mechanics. It's a multidisciplinary program. You will find this program is completely different, dedicated to industrial training and thorough capacity building on the new trade of maritime sector. It's a grooming economy which will give you a lot of job opportunities and research frontiers as far as India is growing. And the Blue Corridor effect, which is planned by Government of India, is one of the important mission which requires maritime engineering growth to happen in the country. So this program caters to expected that capacity building in this program.
Friends, this is part of a material science engineering laboratory which becomes one of the teaching aid for the maritime engineering program. So when you talk about materials innovation in maritime industry, though concrete and steel have been conventional candidates of choice for engineers, for example, we have titanium vessels, high-speed craft boats made of fiberglass. These are all advanced materials which actually do not come across conventional standard design code of practices. We conduct box furnace test, tube furnace test, vacuum arc melting, induction melting, vacuum induction melting, vacuum sealing unit, which are all present in this laboratory is a small segment of material science laboratory. Friends, a typical furnace where the operating temperature for testing specimen can go as high as 12 degrees Celsius. Generally at room temperatures and ambient condition, the mechanical properties will not alter much. As you see in the course lectures, you will notice that strength of the material get degraded when the temperature rises beyond 600. Therefore, when you talk about fire resistant design, you must also choose an alloying element such a manner that the strength doesn't degrade beyond 600 degrees Celsius at all. Welcome to the ambience of IIT Gandhinagar lecture theatre. This is one of the interesting classrooms where the maritime engineering classes will be conducted. We have got state-of-the-art projection facility and good audio visual recording systems. Once the lecture is over, you see the system here. We can generate the PDF files of the lecture directly and you can email the PDF files directly to your email IDs. So it's a state-of-the-art facility we have in IIT Gandhinagar where the lectures are lifetime recorded and shared with the students immediately. This is the IIT Gandhinagar library. This has got all collections of books which are referred as the standard textbooks and references for the course and the program. It also has lot of online editions of design code of practices and reference materials and e-collections of various video lectures of international courses and programs related to maritime engineering. We will be taking you around to the advanced material manufacturing units. So you will have state-of-the-art facilities available at IIT Gandhinagar. So welcome to the program to join MTech and PhD at IIT Gandhinagar Maritime Engineering. So please try to enjoy and take the advantage of this to the maximum. Welcome to the program and welcome to IIT Gandhinagar. Friends, welcome to the 31st lecture on fabrication and installation of maritime structures, a part of the SwayamPrabha course on maritime structures offered by the Department of Maritime Engineering at IIT Gandhinagar. Friends, in the last lecture, we discussed about the steps involved in fabricating one of the offshore structures type, the fixed type platform, which is a jacket type platform. We discussed about the importance of choosing material, the quality control, then the steps involved in procuring material and what are the various components which need to be fabricated before we do the load out preparation. And we stopped at the point where my entire jacket assembly is ready for load out. Okay. So, we checked the components, we assembled them, we welded them, we also identified appurtenances like boat landing, cathodic or anodic protection. We did all those things and then we did also check the quality control of corrosion resistant painting and then the whole assembly of the substructure is ready for load out. Now, continuing from that point of the sequel of this lecture, welcome to lecture 31, discussing further on fabrication and installation of maritime structures. Before we launch a maritime structure like an offshore platform, there are few steps involved to check and assess the requirements for successful launching. One is, of course, importantly the site survey, where we need to assess the complete route of transportation, the sea conditions, weather window, etc., and of course, the soil conditions at site. We have to ensure that they are all suitably assessed in the design stage itself before we start doing the launching. Then we need to also assess the possibilities of successful transportation, which is generally done using a barge, which is the float over method. So, we check the barge capacity, the crane carrying capacity and the weather window, and we confirm that the transportation through the barge float over is possible. Then we start looking at the launching operation, then appending, positioning, pile driving, grouting are all followed after launching. Then we do the final fixing of the top side and we make the complete platform ready. So, let us talk about some important points related to site surveying. The site surveying job includes detailed geotechnical investigation and a thorough bathymetric survey, which confirms the location of the site chosen for the platform commissioning is taken care of as per the design requirements. Then the geotechnical conditions prevailing at that site can accommodate the design of the piles which has been done, and en route of transportation also confirms enough water depth, and of course, the climate, weather climate or the wave climate is suitable for transporting the object from the fabrication yard to the site. So, detailed geotechnical and bathymetric survey report should be ready upfront as a part of the site survey. Metocean data also is important because this gives me a cohesive information about the weather conditions, the wind condition, the current prevalence, whether the wave and wind directions, humidity, temperature, rainfall and sea swelling, etc., on a specific window during which the transportation is going to happen. Seabed soil investigation conducted at site report should be thoroughly analyzed so that the pile driving can be done feasibly within the required time. So, site survey becomes the most fundamental part of this whole process of fabrication, installation and commissioning. So, we need to do this very carefully and the reports need to be filed with an updated information available at the site. Transportation is a very challenging part, I should say, is the most difficult part in the whole launching and commissioning process. It is the most difficult part. Okay. Transportation looks like as if you load out the jacket on a barge and then you append the jacket. It is not that easy because there are lots of instances where the whole assembly of the unit has got completely derailed and we lost the unit during transportation. So, one has got to be very careful. So, if you are planning to transport the jacket via a barge, so the capacity of the barge, the crane uplifting facilities, the conditions, inspection, quality control, all should be followed thoroughly so that the barge is inspected for its capacity carrying of the jacket, as well as it is also possible that the barge is in a good condition to sail from the part of from the point of fabrication yard to the site of investigation or installation. all C fasteners are to be in place, and one has to also do a thorough stability check of the transportation part. And if I am going to use a tow out using the tugboats, then one should also see the location and the number of tugboats and the capacity where I am going to tow out the barge to the site from the fabrication yard. So, transportation becomes a second step of confirming the launching operation. Now, this picture shows you a very clear idea about how jacket is actually transported from the fabrication yard in open sea to the commissioning site. So, one can see a closer look at this jacket. Partly this is painted in red color, partly in green color, and you can see this part which is having a different color, okay, indicates the corrosion, anti-corrosion treatment done, and this part also as an indicator that at what level of immersion the jacket will be lying or will be placed in the sea condition. One can also see the top mounted pockets which are sealed, which are actually fasteners, which are now going to hold the top unit on this. These holes are, interestingly friends, are the component where the skirt piles and support piles will be driven, and one can see the main legs, the braces and the connections which are thoroughly inspected and welded, and one can also see the facilitating part where these are all the fasteners which are helpful in handling and jack rigging them during the welding processes. Okay. One can also see the complicated amount of steel material involved in this and the boat landing part and so on, which are attached as appurtenances to the jacket, and the whole jacket is kept on the barge. You can see this is the barge, okay, this is the barge, it's kept on a barge, it is supported, okay, and it rests on its weight. There is no crane ancillary support given to this, rests on its weight. It does not slide on the barge because there are stoppers available. You can see this portion is not horizontal, it is tapered, and the jacket cannot slide out while the barge is in motion. Okay. Then these are the vessels, the tugboats, which are trying to drag and push the barge from the fabrication yard to the installation site. So, this is a very typical load out operation happens during the jacket transport of a maritime structure. During launching, what are the steps involved? Let us see them in detail. So, there are two ways I can do this. One is the skid way, the other operation is push off. Skid way is sliding using a rail, push off is actually using an external jack to push the unit from. Let us say I have a fabrication yard, it's a fabrication yard. So, the jacket is placed here, and so on. So, now I have rails on which this jacket can be slided, okay. And at this end I can draw the figure. At this end there will be rocker arms which, when the jacket is placed, when the jacket is moved over this, will help to twist it and load it on a barge. This is a barge. Okay. So, skidways, these are skidways, and there can be external jacks available here to push this into the barge. So, skidways and push off are type of operations which are done to launch the jacket from the fabrication yard onto the barge. So, one has to prepare the skidways and launch the runners. So, these are the runners, I can mark them here, on which the jacket will get sliding. So, one has got to launch these runners, position the jacket on the skid beams, and then secure the jacket with holdback system. So, the whole jacket should not fall into sea. So, there is always an arrangement where to hold back the jacket with the cranes, so as a support system. Okay, the hold back. So, make a hold back arrangement, it's a support system, so that the jacket does not dive into the sea and you lose the object. Then slowly and gradually initiate the push off. So, as the jacket moves from the fabrication yard on the skid beam and the rail towards the barge, the weight is shifted gradually to its top side, and then it will start diving on to the barge. So, while diving on to this, you need to control the jacket launch, because once the jacket is launched on the barge, because of the weight at this area, the barge will now experience a moment. So, one has got to have a counter effect on this, which will be gradually released using a crane landed on here, so that as the jacket dives onto the barge and it is pushed gradually onto the barge and the whole weight is balanced on the barge, there will be a support system which will be holding the jacket and gradually it is pushed off. Okay? The jacket is not simply pushed into the sea and then it is barged. So, there is a control movement of the jacket launch when it goes into water. The post launch operation includes operations like checking the buoyancy, checking the orientation, tow out readiness, and release of temporary launch aids. So, these are the steps and these are the precautions required to be taken care of during the post launch operation. Once the jacket is launched on the barge, we need to check its buoyancy and then the orientation, that for example, it should be properly launched. Okay? So, the orientation, because the jacket is of a rectangular size, you can also do this launch this way. Okay? So, that is the wrong orientation. So, orientation should be checked and all the launch releases should be done, all temporary launch releases should be taken care of, so that the launch is done successfully, and the post launch checks the buoyancy, so that the barge is able to carry at the design load. Once this is done, let us see quick figures. So, once the jacket is placed on the barge, it reaches the site of installation. Okay. So, the skid beam is kept horizontal initially, then this is a skidway and the barge runner contains all the skidway. Gradually, the skid beam is released. This is the jacket. Okay, this is jacket. Let us say skid beam is released. So, when released and it is pushed off, it dives. So, at this point, if it is kept this way and then dive, the weight is still here. Okay. If you keep it horizontal and make it dive, the weight will move towards here. Okay, that is very important. So, you raise the skid beam, the jacket is here, the weight is here because you have raised it. Okay, and gradually roll this end and push off the jacket. So, we call this operation now towards appending. Appending is operation where the jacket is rotated from horizontal to vertical, because now when you launch it is more or less horizontal, right. You need to make it vertical because the jacket has to stand like this. So, you need to make it vertical. This operation of shifting from the horizontal position gradually towards vertical position is called appending. The jacket is rotated at the rocker end to do appending carefully. Obviously, friends, when you have got a barge, when you have got a huge jacket structure on this, when it is appended, the barge will be pushed to this side because of its weight, is it not? So, one has to be very careful about holding the barge in position, holding the jacket in position, so that the appending operation does not create an undesirable push out to the barge, so that you slip off and the jacket immerses in water suddenly. So, it should be gradual. The buoyancy tanks in the barge is used to maintain stability of the barge during this operation. Okay. So, appending is again a very challenging job. So, appending is actually the jacket become horizontal and gradually at this pin point is rotated and the jacket becomes vertical. Okay. This is a barge. So, this operation is called appending. One can see the figure how appending is done. So, gradually it is launched and the crane is supporting it. Then the barge is balanced with additional buoyancy tanks. During that, you can see the counterweight hanging it and holding the jacket. So, slowly it is released and the top end is pushed up. So, the jacket becomes vertical from horizontal launch. Okay. Once it is appended, then I have to do positioning, where the jacket has to sit on a specific location where the piles are to be driven on the seabed, right. So, what are the steps involved in positioning? Stabilize the appended jacket first. How do you do that? Use buoyancy tanks, append the frames. Then gently tow the vertical jacket. Now, the jacket is vertical. Tow the vertical jacket to the exact location coordinates using multiple tugboats. You can gradually do that because jacket is now floating. You can hold it on the top and using tugboats you can gradually tow it to the website where the exact installation has to happen. So, you match the coordinates of the navigation system from the launch barge with that of the GPS systems, so that you know exactly where the coordinates are on the seabed and where are the coordinates of the legs. So, you match them correctly and gently tow them. Then you do fine tune heading and rotation of the jacket to maintain the orientation. Then you do the tagline control. Sometimes people also use ROVs to guide this alignment of the jacket with the pile locations. Then once the coordinates are established, then lower the jacket slowly. Okay. Now, the jacket is vertical, you are holding it with a crane, crane is supported on a barge and the buoyancy tanks balance the required amount of upward forces. The coordinates are matched with the GPS, then now you gently lower the racket. Then let the jacket rest on the seabed. Finally, position the jacket, perform the checks, coordinate matches, then place the jacket in the final position. So, positioning is also equally a difficult job, but it is more or less assisted using ROVs, using GPS coordinate matches, and relatively positioning is simple. I am saying relatively, okay? Relatively it is simple. Launching and appending is the most challenging part. Once it is done successfully, vertical towing and positioning is relatively easy. Okay? Once the jacket is now in position, we do mud matting. Mud matting is actually a template where the jacket exactly will rest. It is very difficult to orient each leg of the jacket. So, we do a complete mud mat. The mud mat is placed on the seabed and the jacket fits on the mud mat. So, lower the jacket slowly until the mud mat at the base of each leg makes the first contact with the seabed. I will show you a mud mat here. It is better if you see this in this figure. Mud mat is seen. I will show you this figure. A jacket assembly. This is the mud mat. Okay. This is the mud mat. So, this is the entire jacket assembly. The mud mat rests on the seabed slowly. Okay. The mud mat is made to rest on the seabed, and one has to ensure that all the points equally touch the seabed and the touchdown is uniform. There should be no inclination during this operation. So, it should be having an uniform touchdown. So, that will ensure the jacket is vertical. Okay. This can be achieved through ballasting, tagline control and ROV monitoring. Okay. Mud matting is done on site. It is a difficult task. It is the most challenging task where the efficiency of the jacket installation is challenged at the most important point here, mud matting. Let the mud mats penetrate the seabed slightly. Okay. Check the levelness and tilt. We use acoustic transponders to do this, as they will give you the angle of rotation. So, you set the angle of rotation correctly to 90, so that they are vertical. Stabilize the jacket against the lateral movement. You can do this using suction, and of course, self-weight of the jacket is also approximately about 80,000 tons. It is a huge mass. Then verify the final mud mat seating through ROV inspection before you proceed to the pile driving operations. Once the mud mat is done and the jacket is held vertical, pile driving is done. You can see the figure here how mud matting has been achieved. You can have corner type mud matting, you can have square type mud matting. Corner type mud matting is for every leg independently, square type is for the whole base, though it is expensive, but this is simpler compared to this. So, people prefer this. Then once the mud matting is achieved, one can do pile driving. The steel piles are driven through the legs and ensure foundation stability. So, I will show you a figure where the pile driving is done in the jacket platform. There is a barge holding the pile is driven through the jacket, and then once the pile is fixed, the annular spacing between the pile and the jacket has got to be filled. That is called grouting. Okay, the annular space is filled, it is called grouting. Let us say this figure. The yellow one is the pile, this is the thickness of the pile. The annular space is this and the jacket leg is this, and the grout is filled through this, and grout is inserted in the annular space. This is the grout hose, and the grout goes through the annular space, the space between the pile and the jacket leg, and the grouting is done using cement grout, and that provides the final structural fixity of the leg to the pile. It is to be done carefully and inspected at every stage, because this ensures perfect fixity of the leg to the pile. So, this is a very important step to ensure the completeness of the successful launching. Once it is done, the final fixing and topside installation has to happen. Then one can do the boat landing and upper tenance as fixing. One can lift the top side, bring it and locate it here. Risers can be connected and one can do the final commissioning. The steps involved are as this: prepare the topside module for a loadout, use C fasteners and transport the topside to the offside. Position the installation vessel, crane barge, etc. using dynamic positioning system. Lift the top side, align with the jacket legs and then try to fit that onto the jacket top. Lower the top side and land it on the jacket legs and be sure that the landing is soft. Complete the final bolting and welding and hook up the electromechanical systems between the jacket and the top side. Perform commissioning then of the utility system safety equipments before you hand over the site for inspection. So, this is how actually the jacket installation on the top side happens. So, you bring the top side, hold it and you align them with the jacket legs and insert them perfect landing and bring it and fix it here on the legs. Okay. So, we call this operation as deck mating. Okay. Once the deck mating is done, the full platform is ready, then you start fixing the operational building modules. The building modules are told like the derrick, then the crane system, then the living quarters, electromechanical equipments, helipad, all these are then fixed on the top side on the respective locations. Then the platform is now ready for operation. Then you assess the platform using 4 procedures. You do condition assessment, maintenance, control and safe operation. So, condition assessment is done only when the repair is required on an emergency case. Of course, you do continuous assessment of the jacket to prevent any future mishaps. You determine the damage indices and carry out non-destructive tests and check the integrity of the platform using structural health monitoring scheme for a real-time monitoring. Condition assessment, friends, can be done by different methods. One can do visual inspection, one can do liquid penetration test. You can also do magnetic particle inspections, eddy current testing, ultrasonic inspection and wireless sensor networking, which is AI influenced system. So, people also use sometimes robotic crawlers to look into the surface testing of any connections and vessels. These are generally done on boilers and electromechanical equipments on the top side. Eddy current testing is done for the connections or the fixtures for any leakage. Magnetic particle inspection is done underwater to check again the leakage or the connection riser connections for the joints. There are different steps involved in structural health monitoring of a jacket platform. You monitor the key members using strain, vibration and corrosion sensors. Track the environmental loads using wave and wind sensors. Perform vibration analysis to detect the stiffness loss or the fatigue loss. Use ROVs and drones for underwater and remote inspections. Analyze the data for anomaly detection and life prediction. Integrate this data for maintenance planning using AI tools. Of course, this lecture does not cover about the scope of SHM health monitoring of these platforms. The system architecture is defined in the screen here. This is central control console. If you have got 4 units which has got to be monitored parallelly, the system architecture enables to connect them using RF communication channel. Once it is connected, then the sensors, the wired sensors can connect them to underwater and wireless sensors connect them to portions above water, and we see a sensor network architecture here. All these sensor networking is then connected to a central console where the plant is controlled by a computer stationed on the top side itself. So, there are some gateway sensors used above water and below water. So, above water are connected using wireless and below water are connected using sensors. And friends, once the sensor networking is completed, one can do the condition monitoring on a periodic basis. So, friends, we have seen one example where a fixed offshore platform, jacket platform is installed, fabricated, towed, launched, appended, commissioned and ready for use. I will show you a quick video, animated, which helps you to understand how a floating platform is also installed. So, we are talking about a triceratop. So, to understand how a triceratop behaves on numerical and experimental simulation, I will show you a video. Furthermore, I will show another video where the floating platform is installed in different steps, which are explained there, similar to what we saw in the jacket structures. Hope friends you enjoyed this lecture, you understood partly how the installation happens on these kind of structures. It is the most challenging job, it is the most expensive part of the offshore construction. So, please have a read of these lectures again, understand them. There are many videos available in the public domain. I request you to look at the videos of these to have a better understanding of these, and then should you have any questions posted, please let us know. We will answer your concerns and questions in the SwayamPrabha website in the discussion forum. Thank you very much. Namaste.